Hello, and thank you for joining this webinar. We are talking about problem solving in environmental monitoring today. I'm Mike from Golioth, and I'm joined by Keenan Johnson from the Ribbit Network. Keenan, welcome.
Hello. Hi. Good to see everyone, and great to meet you, Mike, and thanks for having me on.
Yeah, absolutely. It's so nice to have you here, an expert in the field. You are the founder of the Ribbit Network, which we're going to explain in just a few moments. But I think maybe what we should jump into on this is kind of defining what things we consider environmental monitoring, because it can mean different things to different people. So when you hear that term, like what comes to mind, what things are important, what does that really involve?
Yeah, definitely. Well, it's a super broad term, and I think a lot of people can take it in a lot of different ways. But what I think about is, it's you're looking at the world, specifically like the sort of environment that exists outside of buildings. So out in nature, whether that be walking around in the street or in a forest or in the sky, under the ocean, wherever it is, and you're observing something about that physical world. And it's usually things that you can measure, and people measure all kinds of things. So there's sort of like really, I'll call it old environmental monitoring, which is, people went out and they like looked at the sky and they wrote things like almanacs, or like, newspaper columns or books about what they saw that was happening. And we've sort of just really progressed that idea. So now we have really advanced fields of environmental monitoring, like weather radar is a really advanced one. We can very accurately predict when and where it's going to rain. And that set of tools and satellites and sensors is very advanced. But there's a ton of other things that we have that are sort of very new that we're still learning about and trying to figure out what they mean, like air pollution. So particle matter is a good one. That one's been really growing in the last few years. And kind of all those things live under this category of environmental monitoring, which is like we're looking at physical quantities on the Earth and trying to use those to understand something about this place that we're all in.
Yeah, I think that example that you bring up about particulate matter is one that really has bubbled up with the prevalence of forest fires lately. And so people that are very far away from those forest fires are affected by them. And the data for those networks comes from somewhere. But one of the things that I took out of your webpage is reading about how you came across CO2 monitoring and thinking that the data for monitoring CO2 across wide areas must just be readily available. But it's not. So maybe you want to take a little bit of time to talk about the Ribbit Network and like where the origin came from with that.
Yeah. Ribbit Network is the project in the org that we're talking about today. And for me, it started out, I didn't have an intention to like, it was just a learning idea where I've been able to work in climate, and most of my professional work has been around sensors and engineering and how to connect those things. And, of course, I have a very like scientist approach about things. So I was like, great, like we have this problem that exists for climate. So we have all this CO2 and other greenhouse gas emissions. Okay, great. Like that's the problem. And so how do we measure what that is and where they come from? And so that was sort of the question I had. I was like, wait, I actually don't know how we do that. Like I know that we know it's increasing, but like, how do we know that's increasing? And then even more specifically, like, how do we know where it's increasing? So like, where are the emission sources?
Yeah, and it would be so convenient if our weather radar could just also like detect CO2.
Yeah,
because we have the weather radar network out there, but
totally,
it's not really made for it.
Yeah, and I think I had seen recently the success of particle matter detection networks. Those are starting to become very popular. So looking, an important distinction for most people is there's particle matter, and then there's like gaseous sensors. So particles are like little tiny chunks of things floating around that you can breathe in and out. And those are detected in one way. And then gas is obviously not particles. So CO2 is a gas, and you detect that in a different way. And so that's, I started looking around at that. And one of the things that I pretty quickly realized is there are not very many sensors for gaseous detection. So we have a few. There's, quite a few, but they're mostly really science-oriented sensors. And, in the US, the EPA and NOAA operate probably like 20 or 30 of these sites. And they're mostly where people are not. So they're sort of useful to tell us, like, globally, we have this problem with greenhouse gases, but they're not really very useful in, like, where is the problem. And that's sort of the key bit of information when you're thinking about, like, okay, how do we go fix the problem? We're going to take action. And in order to do that, we kind of have to know, like, where the problem is, and then are our actions working? And so I was like, okay, well, great. Like, this seems not that challenging, I guess, like, from all of the problems that we have solved as society. And I think I have some idea, knowledge. I was like, well, why not? Like, why can we just build this thing? Like, we should have sensors. And that sort of started off the whole journey.
The verification is really important, right? So, like, we somehow measure we have this problem maybe with like those 20 sensors across a really large area. And then we start to make changes through, industrial regulations, or maybe the types of fuel mixtures that we're using, or trying to get more mass transit. And you assume that it's made those changes. But if the sensor data is really sparse, then there's no way to verify that.
Yeah. And the sort of government agencies do a really good job of trying. They're trying to do it, but they operate on these super limited budgets, and the tools they have available are pretty limited. So a lot of the monitoring that's done by the EPA for greenhouse gases is done with these field teams. So it's like, they load up a bunch of science equipment in a van, and then they drive out to somewhere and they set it up for a couple of days, and then they go home. And so that's, it's just very time consuming and expensive, and it's really good. Like, that's really accurate data, but it's like, okay, what's the next step beyond that? Like, how can we take that and advance that idea to be something more like the weather radar concept, where it's something, you're a city council member should be able to pull up a heat map and say, like, okay, how's our city doing today in emissions, and how did it do last year? And did the law that we pass, did that work? Did that have the effect that we wanted in this area, for example? That's the kind of thing that city council is doing all day, every day in most cities in America, and they're mostly doing it they're just guessing. We think that it worked.
And so instead of sending out people in lab coats in vans, which that does kind of remind me back to the Farmer's Almanac that you mentioned before. But instead of doing that, the solution that you've come up with is to say, well, can we actually just get affordable sensors and send them to people, or have people build them or make them as widely available as possible? So how did that idea come about, and what is it like
totally
to add a sensor to the network?
So, it sort of evolved organically, like me being a sort of maker-oriented person. I was like, well, can I make one as the first sensor? Like, can I start? What does it take to put together, like, sort of the lowest cost sensor that seemed reasonably accurate is kind of the trade-off that you always make in sensing. And so I just started putting it together, and I just was talking to people about it. And it became obvious that other people were like, oh yeah, that does all make sense. Like, I would also like to build a sensor. And so I was like, great, like, I'll sort of write down what I'm doing and put that out there into the world. And if other people find that compelling, and that other people just started to kind of sort of collect in the project, and people were really interested in it. And so now, like, we've got a big community that exists in the open source who are building sensors. They're contributing to the design. They're making it better. We've done 4 major versions of the sensor, and most of those have been very community driven, where it's all kinds of people contributing different skills, whether it's to the instructions for how you build it, or the mechanical design of the enclosure, the electronics, or the software, or whatever it is. So that was just convenient, like, and it sort of happened naturally. But I think also along the way, I realized that, being in the open source is very important. One, it's very important for people to trust this thing. So you're putting the sensor out there, and if you say like, I want my end goal to be that scientists and city council members are using this data for something, they have to trust the data, basically. And there is no version of that trust that doesn't come from a very transparent stack about like what kind of sensor collected the data, how was it processed along the way, and just sort of like who had the data at any point in that chain before I can make a decision about it. And so that it really made sense the more and more for this to be a totally open source thing and keep all that data in the public domain. And yeah, that kind of led us to, we're now a 501c3 not-for-profit organization. So, we're tax exempt IRS. It's very boring stuff. But the point is that we exist not to be a company to make money, but to serve this social purpose, which is twofold. One, to give people just a really great jumping off point for, hey, I'm interested in climate and sensors and data, and I want to look at an example of how do you put together a sensor and have this experiential learning process related to that. But then two, like, how do I use that experience to contribute to some body of work and knowledge and community, which we think in sort of the longer time scale will really make a difference in science and policy and everything that's important for climate.
All right. That's really great. Let's take a look here from your webpage. I have just a picture of one of the sensors here, yes, which gives us a hint of where the name of the network comes from. But so what is the enclosure here? What is inside of it? Yeah.
So, we're called Ribbit Network. We call our sensors the frogs. So that's what you're looking at. The name is just sort of just like a fun kind of thing. It fit well. Frogs are, they call it an indicator species for climate change. So they're very temperature sensitive. Their habitat is very temperature sensitive. And so they're probably the species in the world that's like one of the most affected by climate. So it's a great sort of mascot and icon for the project. But then also frogs are really cool because they kind of create their own network, right? They're all creating these ribbits to each other acoustically. So they have an acoustic monitoring network in their habitats that they live in. Which is very similar to how we think about the Ribbit Network as this very large distributed network that comes together in a collective body of information. So the enclosure is a 3D printed sort of box. You'll see kind of, there's the bottom box, which is like where all the sort of compute and electronics live. And then the top sort of like stacked pancake cone looking thing, that's the head of the frog. That's a shroud. So it's a couple layers which keep rain and sun off of the sensors, but importantly allow air and gas to come in and out of the sensor, which is obviously the quandary of building a gas sensor that has to live outside, is it needs to be exposed to the outside, but also stay waterproof. And yeah, we're really proud of the enclosure. We've done a lot of work on it. It's actually gotten much better even since we did this picture. So I would definitely encourage you to, like, if you're interested in it, to come look at the instructions or chat in our Discord community and kind of look at the newest, latest, and greatest enclosure.
And we didn't do it ahead of time, but if you do want to share anything on your screen, I'm hoping we can get that set up. I'm getting used to the StreamYard controls here, so thanks everyone for rolling with the punches on this. So interestingly, you mentioned that just a bunch of friends and people that are interested are getting in on this. Is it open to wider use than that? Like if a company was interested in, say, like supply chain monitoring, like, okay, we have a sustainable supply chain and we want to put up some environmental monitors around our production facilities to make sure that we're not changing the environment around our facility and add to the network. Is that a possibility? Yeah, definitely. I think that's one of the really incredible things it's different to think about when you're thinking about this open source nonprofit organization, is collaboration and making the whole system open is the core thing, which is sort of the opposite of how we think about, companies working with each other normally. It's like there's all these barriers and walls legally to use stuff from other companies, but that really doesn't exist
for us, which has allowed us to create a lot of partnerships. And so there's sort of two ways that we think about working with corporations. One is, which we've had great success with in the past year, is like corporate just learning opportunities internally. Most companies and corporations in industry are faced. We've all been a part of the problem in the past, and we're all going to be a part of the solution going forward. So you're having to pivot your entire workforce and company around a new, more than anything, just a philosophy of thinking that just in the same way that you're going to manage budgets, and you're going to manage your emissions and your environmental footprint. And so every choice that you make, just like now you consider how much does this cost? Like that's sort of a factor in kind of every decision that you're making if you're working today. You kind of have to start thinking about how do you manage the climate and emissions categories for those sorts of things. And so putting together sensors and deploying them, whether it's through a local school partner. So a common model that we do is like a company funds sensor kits, and then they deploy those with schools, or like we just did one in Boston where they went to a local Boys and Girls Club, which is aligned. It's a totally aligned stack. So it's like companies often have more money than sort of the Boys and Girls Club local chapters, right, to buy hardware like this. And it works perfectly. It gives those STEAM learning opportunities to the people who probably don't have them otherwise, and sort of aligns with the employees of like, hey, we're going to do this in sort of a really new, interesting direction that's physical based. We're building a sensor that has interesting capabilities.
I love that.
Yeah.
The thought of like not just like having a learn to solder kit or some like breadboarding exercise, but actually getting the kids into building the piece of electronics and then like seeing the data appear on a larger network, I think is really empowering.
Totally. And we offer sort of like learning projects and curriculum that we publish along with the sensors. It's designed to help if you're an educator or a parent or whoever you are, like an after school program mentor, to say like, how do we start getting people to look at the data and do something interesting with it, and just start arranging your thoughts around this idea that the environment is a thing that you can measure with technology, and then you can use that to learn something about the area that you're in, and even more powerfully starting to move in the direction of behavioral or cultural or systemic change wherever you are.
And I think on a more, I guess, selfish note, like having a company hack day where like you get to build some of these and someone takes them home, like that's, or puts them up at the office. I mean, I think that's a super fun time. But then again, like really at the beginning, I'm glad you mentioned the Farmer's Almanac, because that really just kind of solidifies a lot of this in my mind. And so you could give these sensors out and have people building these sensors and just have them like writing the data on the refrigerator every hour or day or whatever, and then sending it and compiling it into a book and sending it out. It's not that we haven't had that data in the past, but the transformative thing now is being able to collect it without relying on a person, so that there's less human error and you get the regular readings and all of that stuff. But you also mentioned like being able to trust the chain of that data that's coming in. Yeah. So what was that challenge space like when you first started on the project?
Yeah. And that's sort of been, I think you're absolutely right. Like the way that we measure CO2 is not new. Those sensors have existed forever. And when I say sensor, I mean like the thing that's literally like checking the CO2 in the atmosphere. It's not novel. What is sort of novel is the ability to deploy, I'll call it IoT sensors for lack of a better term, but sensors that can take that data and publish it up to a central database in sort of a trusted way, cheaply and easily. That's sort of the new thing that's really only come into its own in the last 5 years probably, where it's started to become easy to think about that. And for us, I mean, it's still not easy is the other thing. So it's probably the number one barrier that we had early is like, okay, how do we get this stuff into the cloud? And we've been really lucky to work with a lot of great partners that help us do that. So we started off the project, working on Raspberry Pis with another company called Belina, and they're excellent.
Oh, yeah, I know them.
Yeah, and they work really well for Raspberry Pis. What sort of they solve the problem of like, how do you update these devices and make sure that they're online? Raspberry Pis weren't a great option for us for two reasons for the long term. One is, the supply chain of them evaporated during COVID. So it was just like, well, we had the choice of we either just stop building, we just cancel the project, or we switched to a different thing. And so there were no single board computers that anyone could reasonably buy in the last like 2.5 years that work with Belina. And so we're like, great, we know we need to switch to a microcontroller. We also want to do that for other reasons. Like we're working on a solar powered version of the sensor. And so that just makes more sense to do on a really low power device. And so we're like, great, how do we take this ability to plug a sensor into the network, let it get software updates continuously from sort of our trusted source of the network, but then also be able to push data up and down into sort of like our cloud backend infrastructure in a trusted way. And, obviously Golioth has been sort of the key enabling technology for us there. It's possible, like we could have written all that software, but because we're all volunteers and this is a nights and weekends project for us, it was like, that was just not going to be practical to do that. It was like, that was going to be a years like that. And it's sort of not what our core thing that we care about is. Like, we want it to work and be good, but that's not our primary value add into the world. Ribbit. It's like, we're here to like enable people to have these learning experiences and to do something with the data on the other end. And the sort of in-between steps is very technically complex, but also not our core competency. And so it was just, I think, really serendipitous that Golioth was sort of starting to be prevalent right at the time where we were really running into that problem wall of like, okay, like, how do we do this? There aren't really a lot of great tools to do it that are purpose-built for this. Like, Google IoT just shut down right around the same time. So it's like, okay, well, that was one way that people did it. So that's gone. If you Google this problem, there's a lot of people just like pushing software images just to a GitHub repo, and then your devices just check it and then download from that. And that's not a very robust solution either. And
we haven't talked about it, but like your devices are actually going to be running on people's home networks because it is distributed. So I think having that like secure channel for update is kind of a guarantee you need to make to people that are going in on the project.
Yeah, totally. It's it is like, by allowing an IoT sensor into your life, you're making this compact with the organization on the other side that like you trust them basically to not do anything nefarious with that. I mean, really luckily for Ribbit, we can do everything in the open source. So you can go verify what that is and what that chain is, but having it happen in a secure manner is really important. And Golioth is really great for us because we can not only pull software updates down from the device, but we push our data back up through the Golioth service. And so that all runs in sort of your secure layer. And the other thing that's great is sort of the security keys problem. We only manage one set of security keys, right, for device updates and pushing the data back up. And that's really not very easy to do with any other solution.
Is that because you had like a different set of keys for like managing the devices and a different set of keys for uploading the data before? Yeah.
So I think that's the way that it's done, like classically in IoT. Or if you ask people like 2 or 3 years ago, that was the only way that you could do it. And there aren't really very many easy ways to say like, I want one set of keys that gives one device access to both. Which is really important. A lot of that little friction stuff is really important for us as people who set up our sensors are not experts in this. And then right now they think about the keys, right? So it's like when you register a device, you get a set of keys and you have to input that into the device. Maybe that will be automated for us one day, but for now, it's sort of part of the process, and it's kind of cool actually that people get that learning experience, whether they can understand what that means or not. But it's something that they have to deal with, and they can go learn about if they'd like. But it's really nice to do just one set for us.
Right. Well, I'm sure we can go deep on the data side, and we should do that. But before we get too far away from it, let's talk about the hardware one last bit, because your path sounds pretty common. Like you started with something you were comfortable developing with, and starting with something that probably has way too many features, but that's where you don't know what you need. Sure. So you start off with that, and then you cost down to something else. Yeah. So when I think about your application, it sounds like most of the hardware of the Raspberry Pi was like, were you even using Ethernet with those, or was it all Wi-Fi?
We've always had a very small number of sensors that do Ethernet. But most people use Wi-Fi. So we did use it on some, but it wasn't the primary thing. But most of the Raspberry Pi features, like we didn't need a screen or like the GPU that a Raspberry Pi has, or like we weren't really using it has a bunch of cores that we don't use. Like we're not running a very compute intensive application. So just from a power perspective, like a Raspberry Pi, you really can't get the power lower than like 7 or 8 watts, which is a lot of power that is just being wasted into the heat death of the universe.
Are you running batteries on these devices?
Some people have batteries, and when we make the transition to solar power, we will certainly do that. Like every solar powered sensor needs a battery system along with it, and so that'll be a really core thing for us. So switching to a microcontroller, right now the sensors are down to like half a watt, kind of continuous, which is a much more doable place. And that's when they're sort of operating, and then you can put it into sleep modes and things. And that's a much more tractable place to say like, all right, we don't need like 250 watt solar panels to make this happen, kind of thing.
And for your application, like how often do you need to take readings to get the kind of information you're looking for?
Yeah, I would say that's definitely an open science question that we work with some of our science partners. We have great science partners and an advisory science board that we work with, and they help us sort of, start learning and start looking at that data and answering some of those questions. Right now, we take readings every 5 seconds. So it's quite often. The theory is that's probably too fast. We probably don't need it to be that often. But in the same way as like you have more hardware than you need, it's better to start with more data than you need and sort of optimize down rather than go the other way. That's a challenging place to be. So we've started from kind of this really high frequency measurement cadence, and we'll see as the network grows if we can adjust that down.
Yeah, and I think, looking at, like you said, moving from the really high draw Raspberry Pi down to a microcontroller is a huge step there. But as you get the network figured out and have the ability to do some more device management, you could potentially, have sleep modes where the device schedules itself for its next wake. And so you end up with, very rare times where it's high draw, basically just when the radio is on and pulling that sort of thing. With your data that you're pulling in, I mean, that starts to be a big challenge. Like, how do you geolocate where the sensors are in order to pay attention to them? Do they have a GPS, or is that self-registered? And like, what happens on the back end with the data for that?
Yeah, good question. We didn't really talk, I guess, too much about what all the sensors it has are, but we have a CO2 sensor. That's obviously the most important one for us. Sort of important in the analysis of that data. We also have humidity, so relative humidity, and then barometric pressure and temperature. And those physical quantities are logged along with the CO2 because that's important from the science perspective of like, if you start analyzing that data, you sort of need those relative quantities as well. But then we also have a GPS sensor, and that's very important for us to precisely locate where the sensor is. There certainly are kind of other ways you can get that location, like that we've explored. And I think that's a big area of like, okay, if you wanted to continue costing the sensor down, the GPS module is a sort of large-ish cost bucket and what it takes to put the sensor together. But there's quite a lot of software complexity to like develop an alternative for that. And one of the unexpectedly hard things that we think about is like, how do we get a very accurate altitude for the sensor? So it's very easy for people to say like, I can look at a map when I set up my sensor and place where it is in latitude and longitude. But it's really quite difficult for them to say, but how high is the sensor very accurately? And that's important. It's very important for gas monitoring because the gas moves up and down in the atmosphere, and that really affects how you do the analysis. So that's sort of an unsolved problem for us of like, how do we get an accurate altitude? Can we just rely on the barometer, for example, for altitude? Or is there some other clever way that we could do it where we don't need the GPS? And if that kind of problem is interesting or exciting to you, I'd say come work on it with us in the open source community.
Yeah, how do people get involved with that? I mean, I looked through your team page, and you have a lot of folks already chipping in, but I'm guessing there's more work to go around.
Totally, yeah. There's sort of infinite work, and one of the great things about our project is most people come in and they contribute their own ideas of like, I think this should happen, and I'm excited to do it, and you can go push that forward. So we work in a few ways. There's sort of like random volunteers who kind of live in our larger community. And I would say probably the best first way you can get involved is build a sensor, because that sort of is the first place that you can have a learning experience about it. And we publish the designs and everything you need to know on the website, so ribbitnetwork.org. You can find us on GitHub or Google, and I'm sure we'll have all this in the links as well for this meeting. So go there. You can join our sort of chat community, which we host on Discord. Anybody can join. So come in, ask lots of questions. Yeah, whatever you got. Tell us about yourself and what you're looking to learn. And then if you get really excited about the project, we sort of have a core team. And those are people who are putting like, more than a few hours a week, every week into the team and sort of pushing the organization forward. And if that kind of experience is something that you're looking for, we are definitely recruiting for core team members. So technical, non-technical, a lot of the work that we do, we're applying for grants all the time to go fund more sensors or fund more science research for the team. There's obviously a ton of technical work, hardware and software, electrical, mechanical, whatever you're into on the technical side. We're trying to continuously improve our sort of educational curriculum. So there's a lot of writing or like educational experience design that you can think about. So yeah, tons of people can get involved. And I know that obviously Golioth is, if you sign up for URL's newsletter, you get entered into a drawing for a chance to win one of the sensor kits. So that's probably a great, easy step anybody can take right now if you want to try to get a chance for one for free over the next few months. So I definitely encourage you all to do that.
And you can also buy pre-made, like if you're not willing to solder together your parts and flash them, your network has pre-made.
Yeah, we have a waiting list right now you can sign up for. It's if it's not obvious on the website, pop into our Discord and let us know, and we can connect you to how to get it. We have really good instructions, which have preset carts. So it's really like 2 or 3 button clicks to buy the parts yourself. And there's no soldering needed in the kit, which is something that we really worked hard to do. And so you can do that, or we're starting to offer sort of pre-made like kits, which everything in one box from one place, and you can purchase that as well.
And I'm always I like to learn how other projects are doing things. So it's really nice that it is open source. And so we'll make sure to go ahead and put up the URL to your GitHub repo as well. Mm-hmm. I mentioned that we were going to come back to data. And I think, continuing from the, we're not in the Farmer's Almanac idea anymore. So we now have the devices that are automatically reporting data back to Golioth, but then we need to do something with that data. So how are you actually getting that like off of the Golioth network, using on the Golioth
Yeah.
network, and putting it into something like I see there on your
Sure.
website, there's a live data view. Like how does the data get to the
Yeah.
live view?
Yeah, and we have a diagram of this on the GitHub. So if you're really into it, I'd encourage you to check it out later. But the data comes up from the sensor through CoAP protocol, through sort of the Golioth LightDB stream. And then it gets pushed out from Golioth's backend via webhook. That goes to a serverless cloud function, which does like a little bit of sanity checking of like, is this data sane? Like, is it correct? Like, is this from a sensor? Like just some sort of basic error checking. And then it gets pushed from there into our database, which right now we're using InfluxDB, which is a sort of a great tool for time series data, obviously. It's also just super mission aligned because they're a totally open source organization as well. And so that's great. We like that.
We should talk about this afterward because I don't know if you know, but we just rolled out an InfluxDB.
I know. I saw it. We haven't. We've been doing it for much longer than you all had that stream. Yeah. So we haven't. I don't think anybody's looked at it, but that's definitely something that's on our to-do list. Is be like, okay, great. Yeah, like, could we connect it?
All right. So sorry to interrupt. Yeah, so we get the data into your Influx database, yes. And then it just lives there forever.
Yeah, right now it's just living there forever. I think, we have a ton of work. So if any cloud backend people are excited about this kind of problem, that this is probably technically where we have some of the most work is in the backend. So like say, we have an API sort of prototype where you can get access to the influx data behind sort of a proper like HTTP API. That really needs some help in development as well. But you can also get it from sort of the website page that we host. And that's there's this really awesome project that Plotly, which is they're like a front end UI visualization tool. So if you want to make lots of cool charts, you are probably using Plotly in the front end. But they have a whole web hosting framework called Dash. And so the dashboard.ribbitnetwork.org page is a Dash page, which sort of, it's like a Flask Python app, basically. And so it pulls that data from Influx, gets it over to the dashboard, and sort of renders all the sensors in a map, and everything looks very nice.
So I think that, again, people wanting maybe to participate in the Ribbit Network is one thing, but people building their own networks is another thing. So if you could have done the data backhaul differently from the start, like what were the hard lessons along the way that you wish you had known?
I think one of the things that I think was unusually hard for us is that there is no real like super easy way to say like, how do I put a bunch of time series data into a thing and then make it accessible for people? So we had to build sort of a lot of that. Like a lot of people use the data, they want a CSV file. Basically, that's how most scientists are working today. Most scientists are not super API like fluent. So that ability is the most used way that people get data out of our network is dumping it into a CSV via our front end. And that was not intuitive at the very beginning. And we've spent a lot of time trying to make that effective and efficient for people. That's still a big open problem area for us of like, how do we enable that thing without having to create a lot of security hurdles or having, to teach people a ton of tools to be able to get access to data. So like curl is not an effective tool for most scientists working today, for example. So that's been unexpectedly quite challenging, I would say. And I guess I assumed there would have been more like sort of out of the box solutions for that kind of thing, but it really is not. I think the other thing that's been interesting for us is this idea of having a public good and a public data set in the public domain is not common. Most sort of like backend data cloud tools, they rely on the people who have access to the data being behind some level of trust already. So you have credentials to log into a network, you're working at a company, and you have full access and you can do a lot of things. And it's not that I think that we have like necessarily bad or malicious actors, but we have just sort of random people who are learning, trying to get access to the data. And so making that a safe and protected system where you can have access, but you can't mess anything up, is a really challenging, there aren't a lot of easy solutions for that. And so that's why we really kind of have to like build our own API and like do a lot of these things to enable that access to that data, because that's really sort of what we are. Like we're trying to get people the data, but we want to do that in a way that doesn't require a lot of barriers. And that's a non-common use case for us that has been more challenging than I thought it would be.
So a couple of things left on my list that I wanted to talk about are more on the hardware side. And I can just give you both the questions now. We can kind of roll through the conversation that way. The first is these devices are supposed to be outside. Putting a Raspberry Pi outside seems like a very challenging thing. And microcontrollers, not much easier, but a little bit easier. Yeah. And then the other thing is, how have you approached like needing to do updates on these devices? Do you have an established plan for that? And does it take into account different revs or mixes of hardware? Is everything the same?
Yeah. Great questions. So obviously, that's one of the hardest things is like, how do you put electronics outside? And sort of the industry answer for this is, well, obviously you just put it in a totally sealed box that nothing can get in, and then it's great. And that works super well for something that doesn't need to interact with the environment. It's obviously a challenge for an environmental sensor because you need to have the sensor exposed to air, and so there has to be a way to get air in. And that's really challenging to do. But I think it's something that we've arrived at pretty good answer for. So like our mechanical engineering team is excellent. So the enclosure that they've designed, you can 3D print it all. It snaps together. So there's no tool required to get it together. And it creates a pretty good sort of natural way that some parts of it are sealed, some are not. And that the airflow can get in, and it's mostly protected from solar radiation and wind and rain. And that's sort of, the concept is called a Stevenson screen. And we've adopted it to be like a 3D printed version of a Stevenson screen that also looks fun, which is kind of like a non-trivial aspect of it, but I think is really important for the project because climate has been this scary thing. And I would say most like engineering concepts and tools are also not necessarily friendly looking. And so if one of your goals is to inspire people to get excited about technology and using it to solve problems that they see, making it fun is actually important. And so like it has a face and like eyes and looks nice.
Yeah, utilitarian design doesn't necessarily like make you happy or make your life better. And
it does
I
not.
think it's really cool that you've gone to we try to do that with like our conference demos is like, let's not just take a gray box and have it sitting on a table. Like let's have something that people are meant to see and meant to interact with. And those kinds of things, when I see them, I appreciate the designer, especially in making this something interesting in my life. And I think it's cool that Stevenson screen idea that it's not, the shape of it is not because of the Ribbit Network. Like the mascot is because the shape is serving the function, which is it happens to look like a frog, which is nice, and it's really cool. And we've done a lot of work, and the kits that we provide to corporates doing events are the ones that we provide to people are all recycled plastic, which is also not necessarily easy to do in the 3D printing space. And we've spent a lot of time looking at materials and trying to get reliable sources of the recycled plastic. But it's possible to do it. And I think that like we've really tried to think about that as much as we can to keep the environmental footprint of the sensor low, which I'm super proud that we've been able to do it. And then the second question
was what? I forgot.
The second question was handling updates for hardware that's already out in the field. Is everything in the field currently like the same hardware? Or have you had to deal with revs, and what's your plan?
No, we have a ton of different versions out there. So like I said, we've done at least 4 versions, like major versions of the Frog. So we still have some of the Raspberry Pi sensors, for example, running out there in the world. People have built those and they've stayed up. And we've got a few different versions. So we try to make the software sort of like detect the hardware as much as possible. So there are like different versions of the software, but all kind of runs in the one repo right now. We sort of have 2 branches. One was like the Raspberry Pi stuff, like the single board computer repo, and then the sort of new MCU microcontroller universe. So we did those 2 big branches of the software. But within those, we try to make sure everything is like still the same. So we also have probably the biggest difference that we see is connectivity. So like most people are running off of a Wi-Fi connection, but we do have power over Ethernet sensors. We have cellular now that are running, and those all run out of the same code base. And so the hardware tries to detect which one that you have and then give you the connectivity option out of that, which is sort of non-trivial to do. We also have sort of the added challenge of we're trying to make the code base accessible and understandable to the most number of people. So we've chosen to commit into MicroPython, which has been really good for us from sort of a learning opportunity, but is like more challenging sometimes about like how do you make the software work well and really robust in MicroPython. There's less people doing that for sure than in C, C++ kind of standard stuff.
Yeah, absolutely. As far as managing the networks, like, are you paying attention to like what devices are online, what devices aren't? Like, do you have some automation in there to keep your fleet ticking along?
Yeah. So one of the things that I'm really proud about is kind of to software updates is that the whole update process and getting a sensor on the network is all automated. So when somebody merges something into our main branch in GitHub, that gets built into a firmware image, and if that looks good, our unit tests check out. It goes to our test fleet here at Ribbit Network HQ first, automatically. After a few days, usually somebody looks at it, green lights that the sensors are online, and we just say go, and then it gets rolled out to the whole fleet automatically. And so that's a really cool process. That's running all on GitHub Actions, and then we push it into the Golioth API to actually create a release and roll that out to the devices. So super proud of that. It was super easy to set up. And I think that's mostly to your all's credit of like making that an easy thing to do. So, one of the great things about our project is you can go look at that example. You can look at exactly how we do it. And if you're building a similar kind of project, like you should do that. I think because it's super easy. I think everybody has the goal. Nobody wants to be doing DevOps about managing the devices for the most part. Like that is not a fun activity as you have a fleet of more than 2 devices. So it becomes unmanageable very quickly. And so that part is super easy. We have some basic monitoring of how does the device, if it goes offline, which is quite common for a lot of reasons, actually, somebody's GFI trips, somebody turns off the switch that the outlet was connected to, you update your Wi-Fi network and password, or there's all kinds of reasons sensors can come on and offline. If you're dealing with them sort of, they can be anywhere. They can be at a school. It's at somebody's house. It can be at a company. They can be on and offline all the time. And so we have some basic monitoring now. And one of the things, we've got 3 volunteers who are working super hard to create the system that will, in a very secure way, link a device to an email. So the person who sort of is responsible for the sensor can get a notification of your sensor went offline. Now you should go check on it and see how it's doing.
It's so simple, but if you don't have it, it can be a really long time before people realize.
Yeah, people don't Our community is really awesome, and most people who are into it, and so they are checking on their sensors. They're looking at the data a lot, and they sort of notice. But to sort of reach the next level, we really need to add that process. And Golioth has everything there for us in terms of like, it knows if the sensors are online and offline. And part of the challenge and sort of hard part for us is just like keeping, like, how do we associate that to the person in charge of the sensor and do that in like a responsible way? We don't collect any sensitive information, but we do want to just make sure that we're setting a good example that you can never like detect who owns the sensor from an attacker perspective, right? So we're building that out, and I'm super excited. I think that's going to be a big help to the network, is to be able to say, oh, my frog went offline, I should go check on it. And I think, we're excited as well about the future of like being able to start doing interesting detection on the data. It's like, hey, something interesting happened on your sensor. Like you go look at the data. Like this is a good learning opportunity, or something has occurred, because we know that people are seeing that already. Like, that kind of stuff is happening. People are noticing it, and being able to enable those learning opportunities in a more automatic sense is something we're excited about.
Well, I think, like I said before, it would be nice if people are able to follow some examples on putting these out into the field, because if you're sensing something else, around your business or around your home or community, I don't think that the building blocks are very different. Like a lot of the lessons have done there. We've done a little work on like putting some examples out there. One of them is we have a site called projects.golioth.io that has different reference designs on it that you can build with off-the-shelf hardware. And one of them is this IoT air quality monitor. So if people want to go and take a look at what that's all about and the hardware that goes into it, this interesting, you were talking about particulate matter. This has got a Sensorion sensor on it, and it has like a fan to blow air across the sensor so that the particles go in it, which is very different from the CO2 that you're using. And Golioth does have a free dev tier for the first 50 devices. So if people want to try and prototype some sensors, put them up on the network, you can head to golioth.io to put that up there. As far as getting more acquainted with the Ribbit Network, where can we send people?
So ribbitnetwork.org is the easiest place. That has all the links. It has links to our GitHub, our website, the Discord community, email contact, all the instructions. That's all there. So that's probably the focal point. I think we're findable on whatever search engine you choose as well, or if you type us into GitHub, you'll find the page there. But yeah, definitely encourage you to get in touch. We have a newsletter that we send out. But more importantly than that, if you're interested in the kind of thing, like this is a community, so get to know the people who are around it. And I think you'll find that's a much more fulfilling route probably than just focusing only on the technical. So shoot us a message in Discord or on the GitHub discussion forums. We're super active there, and somebody from the core team or myself will be happy to meet you. So.
Well, Keenan Johnson, it's been so wonderful discussing this with you today. I know the whole company at Golioth has enjoyed working with the Ribbit Network because it is such an interesting application, and it's been fun to see where you're going with your fleet. And obviously, it's easy to get behind this concept of more data makes us a better society. So thank you so much.
Yeah, thanks. It's good to see everyone.